Alright, so let's take a look at number 7. How much does Sydney have to invest per month at 9.2% interest compound monthly so she'll have $1,300,000 in her account after 40 years? So we're putting in the money every month. So that tells us that we're working with an annuity. Now we already know what the amount of the annuity is, so we're not using this first formula. We're going to be using this second one. So let's write down that formula. Alright, so now let's go ahead and do the calculations. A is this 1,300,000. So we check real quickly, it's 5 zeros, so make sure when you enter in the calculator, you put in 5 zeros. Alright, here is 9.2%. So write that as a decimal, 0.092. And we're doing this monthly, so N is 12. And we're doing this for 40 years, so a little while. Alright, so let's whip out our calculator. And again, just kind of think we have to be a little careful here when we're entering this in. Make sure that when I put that 1,300,000, after the 13, I've got to put in 5 zeros. 1, 2, 3, 4, 5. And then we're going to have parentheses, fraction key, 0.092, down arrow 12, right arrow, close the parentheses. Go down, parentheses, parentheses, 1 plus our fraction key, 0.092 over 12, close the parentheses, caret key, 12 parentheses 40, close it off. Make sure you hit that down, that right arrow, so you can get back down, and then do our subtract 1. So if we do that, that gives us $261.63. Now sometimes in the textbook they're going to ask you to round up. If they say round up, then you'd round that up to $261.64. Let's try number 8. If after 2 months Zack had to pay $150 in simple interest on a loan of $1,200, what was the annual simple interest rate he was charged? Alright, so we're looking at these two formulas here. And what we have here is the interest. And we have the principal, so we're going to be using the first one. So our interest here was $150. Our principal is $1,200. We don't know what R is, that's what we're trying to find. And T here is 2 months, so we have to put that 2 over 12. We need to solve this equation for us, so we're going to need to simplify. You want to go take 1200 times 2 over 12. So whip out your calculator. And let's go and do that multiplication. So that gives us 200. To solve for r, we divide both sides by 200. Keep in mind that's going to give you r as a decimal. So we need to do 150 divided by 200. And that's 0.75. Which that's equal to 75%. Let's try number. If Latonia gets a 20-year mortgage for $120,000 at 7.5% interest, what is her monthly payment? Alright, this is a fixed loan, so we only have one formula to choose. It's this one here. So that's our formula we want to choose. It's always a good idea, always double check to make sure you wrote down the formula correctly from the formula sheet. Now let's plug in our numbers. Well, we know what P is. That's 120,000. R here is 7.5%, so write that as 0.075. We're talking about monthly payments. So N is 12. And our mortgage here is a 20-year mortgage. So now we're going to throw that in the calculator. So fraction key, we have a 12 followed by 4 zeros, parentheses, fraction key, 0.075, down arrow 12, the right arrow, close it off. Go to the bottom, parentheses 1 minus, parentheses 1 plus, fraction key 0.075 over 12, right arrow, close it off, and then we're raising that to the negative 12 times 20. And that would give us $966.71. And again, you might see in the directions in the book, in my last flush, to round up. If it says round up, we're going to round that to $966.72. So that would be the monthly payment. And again, if they round up, you've got to go up to the next cent. And so we want to figure out how much to pay in interest. So we're going to take that $966.72, going to multiply it by 12 months, and then by 20 years. And then we're going to subtract off the original principal. So we're going to take 966.72. We're going to multiply it by 12, multiply it by 20, and then we're going to subtract off 120,000. So that's $112,012.80. Now, if you did not round up here, if you left it as $966.71, and you did the calculations, you would end up with $112,010.40. So you got to really pay attention to My Labs Plus, because wherever they tell you to round up or not, we'll change the answer. Let's take a look at the next page. After winning a small lottery, Maria has two choices to reserve winnings. She can take a lump sum of $50,000, or she can get $4,000 per year for 25 years. If she plans to invest the winnings in an account that pays 6.5% compound annually, which option should he choose? So option number one, now that's a lump sum. So that's just a compound interest formula. So that's one we're going to use here. So we're going to use A equals P times 1 plus R over N raised to the NT. P here would be 50,000. R here would be 0.065. It's compounded annually, so N's 1. And she would be investing that for 25 years. So let's compute that. Let me type it in correctly. Third time is a charm. So that would give us $241,384.96. Alright, so that's from option 1. Option number 2, she gets $4,000 per year for 25 years. You might think that's the better option, because if we take 4,000 times 25, that would give us 100,000. Well, let's see. Well, if she's making periodic payments, we have to use our annuity formulas. So we're going to have to use this one here, because we're trying to figure out how much she has at the end. So our P here is going to be 4,000. R here is still 0.065, and here is still 1. T is 25. So we're just plugging in the numbers, and now we're going to pull our calculator to do the calculation. So we'll have 40,000 parentheses 1 plus fraction key 0.065 over 1, close parentheses, caret key 1 parentheses 25, close her off, hit the right arrow, and then we're going to do subtract 1, close her off. On the bottom we'll have parentheses, fraction key 0.065 over 1, close the parentheses. And so this would give us $235,550.71. So actually choice A is going to be better. So the first choice, choice number 1. Let's try number 11. The price of a home is $210,000. The bank requires 20% down payment. The house is financed with a 30-year fixed rate mortgage at 5.9%. Want to find the down payment and the monthly payment. Well, the down payment is 20%, so we need to take 20% of 210,000. And if you do that multiplication, that would give us 42,000 for the down payment. Now remember, if they're putting 42,000 down, the amount of the mortgage is going to be 210,000 minus the 42,000. So if we do that subtraction, that would give us 168,000. That's what's being financed. And this is a fixed installment loan. So we're going to use PMT equals P times R over N, all divided by 1 minus the quantity, 1 plus R over N, raised to negative NT. So we'll plug the numbers in. 168,000. Our interest rate is 0.059 when we write as a decimal. We're doing this per month, that's over 12. And this is all divided by 1 minus, parentheses 1 plus 0.059 over 12, raised to negative 12 times, and we're doing this 30 years. Right, so now we're going to put that bugger in the calculator. Make sure you're using subtraction there. I'm going to hit enter. And so that would give us a monthly payment of $996.47. Alright, let's take a look at the last one. What is the effective annual yield on account that 6.5% interest compounded weekly? So again, we're talking about compound interest, but we don't have much. All we have is N and R. That's the only choice we can use. So we're going to plug in. So take that as 0.065. And it's compounded weekly, so remember there's 52 weeks in a year. So we're going to pop that into our calculator. So that gives us 0.067111. Going to move our decimal over 2 places and round to 2 decimal places. That gives us 6.71%. And that would be our effective annual yield.